when we're talking, and don't walk up in front of you unless we covered up the lights. Otherwise, people all around the world know about you. You don't want that. So this graph, the value of the expression when x is 2. So here are your x values on the horizontal axis. So to find this, we come to where 2 is, and then we look at, oh, this is a bad color. So here's the x, we come over here to where 2 is, and then we look at the y value that corresponds with that. So is there a y value that goes with 2? Or is there a point that goes with x being equal to 2? You guys gotta help me. Down here, so you go down to that point and then you come over. If this was a line, you would do the same thing. You go down to the line and then come over. So when x is 2, y is -4. And then, let's see, I'm going to brush here, this is confusing for me. The values of x that makes the value of the expression equal to 2. So in that case, the value of the expression is like the y. So when we come here and we find +2, then we go over and we find the x value that corresponds with that, and that's going to be 5. Does that make sense? Marvis? Yeah. That was your question. Okay then. So let's go to 11. So you have to consider this one here. The landscaper selling black dirt for $20 a yard, plus a $40 delivery fee. And then $40 rental room for a special room, plus $20 per person for the cost of food. So for 11, we have to match one of these with each of these here. So if you have $20 for the soil plus 40, this would be for 1 yard. How much would it cost if you bought 2 yards? How much does the soil cost? 20 per yard. So now it costs 40. How much is the delivery? So that stays a constant, doesn't it? And then if you bought 3, it would cost 60 and 40. So it looks like this starts at 60 and then it goes up by 20 more each time. So if we looked at, so if I looked at this, which one starts at 40 and goes up by 20? They both do, don't they? Yeah. But this here says there can only be 0 or 1 or 2 or 3. There's no in-betweens. That's the point behind this problem. Is there an in-between when it comes to buying soil? Could you say I want 1.5 yards?
Yeah.
You could. They usually like to do it in whole yards, but you could have 1.5 yards of soil. It's just like soil. You can break it down. You can buy a tablespoon. But this over here, this is going to show us soil, I think. And then the other one, why is that different? Well, here we have $40 for a rental fee, but then it's $20 per person. So it's going to cost you $40 to get started, and then $20 for one person and $20 for another person. So you're counting whole people. And the point behind this is that scatter plot. The scatter plot graph counts whole people. You're not going to cut somebody in half and charge them half price. Not too often. You're not going to have a half of a person. So in this case here, it goes $40 for nobody, $60 for one person, $80 for 2, and so on and so forth. So that's 11. Anything else you want to ask? Are we good? You sure? Okay. So you have your graphing calculators? You have to. Yeah, I guess you can. Yeah, you're on this end, so that's nice. Yeah. Got my thumb on it now, just like in the Walter Mitty movie. Yeah. Here's what I'll do. Just cruise right through here. Bring them every single day.
We have code names.
Say again?
We have code names.
You have code names.
Yeah, can
Do whatever you want. What's your code name going to be?
You're going to be prime minister because you're the leader. You're the top of the monarchs. Marx, you're going to be Price. Wait, monarch is monarch system.
All right. So the key with this, what we're doing is we want you to be able to successfully enter things into the graphing calculator. We've done a few things last year, but don't mess with that. Come on,
I'm
dude.
trying to put it back.
You gotta put that. Just don't slide it off. Or you want it slid off because, you know, actually,
Why is this so
it makes more sense
complicated?
if those things would come back like that, because you're leaning back, there's
There.
a lot of mitigations that I question. Wear your mask.
There, keep following.
Well, you need to get a different mask, or you gotta tighten those up.
Did you get like a ski mask? Yes.
Could you have a ski mask?
Yeah, like-
No. You don't want polyester stuff. You want cotton.
Oh, so it helps,
Cotton, the fibers have a,
cotton wool.
it goes back to molecular science. Water molecules are attracted to other molecules that are polar molecules that have positive and negative ends on them. Cellulose, which is the molecule of cotton, cellulose is polar. Water molecules are polar, therefore they're attracted to one another like poles on a magnet and such. Whereas polyesters are non-polar molecules. So like water, you know how it beads up on wax paper? Where it beads up in oil and water don't mix, that's because water molecules have a positive and negative end to them, and those non-polar molecules of oil or wax do not. Polyester is like oil or wax. It repels water. So you get these droplets of moisture that are going through your mask. And if you're wearing a polyester mask, the droplets just go right through. They're much less likely to get caught. They are more likely to get caught in cotton. So cotton is like really, really huge, much bigger. And I mean, that's from my scientific understanding, but I went and I dug it all up on the CDC site. They have it up there as well. Okay, so you have your graphing calculator.
Yeah.
I think if I'm here, and then I can show you on here the keys where I'm going towards. The idea is that hopefully what you have on your calculator is going to be very similar to what I have. If you do not, you have to tell me. I'm going to assume that you're getting it unless you tell me otherwise. I may come around and take a look at some of them as well. So get them turned on, bottom left hand corner. So activity, I'm on page 33, and I want you to look at this stuff as well. Try to put some of it up here for you. We're going to do this first activity here. We're just going to type in x squared minus 15x. We're going to graph it. We're going to put it in an appropriate window. So go to your y equals. I don't know if you have anything in there or not, but just clear it. You can use the clear key in the upper left-hand corner to clear any equations that you have in there. So we're all on y equals?
Yeah.
So if we can all work on the first one, y sub 1, it's probably blue, yes?
Yeah.
Yeah, and you can change those colors, you know, but for now we want to make sure that we can all do the same stuff, the basics. So we want to enter the equation x squared minus 15x. That's right from your book. So the x, we got to use the xt theta key, which is right up here. That's a key for a variable in anything that you're entering. So you have x, and then it's going to be squared So you want to come over here to the right, the up hat shape, it's above the division. So we're going to hit up, and then we're going to type in 2. But if you notice, can you stay with me? Okay, so if you notice that squared is still blinking, isn't it? So what we can do is we could say like 2 times something or whatever. We can put an equation in for the exponent. We're not there yet. We don't need to. But what you do need to know is once you get what you want entered as an exponent, you need to use your right arrow to get back down so that you are then typing bases instead of more into the exponent. So now you have x squared, subtract 15. You don't have to say times when you put the 15 right after the variable. You can just do 15 and then the x. So you got it? All right, now we are going to change the window. The standard window of your graphing calculator runs from -10 to +10 on the x-axis and -10 up to +10 on the y-axis. But not all equations fit into that space, as you know from graphing already. So what they would like us to do is they want us to change the window. So go to the window menu, which is way up on the top, second from the left. Are we there? Mm-hmm. And then it should say x min, and there's a number there. I don't know if yours says -10 or what. But what we want to do is we want to change that window to -10 if it's not -10. But you don't use the subtraction. Don't forget you have to use the negative in the parentheses. So -10. And then you can just hit enter. And the maximum is going to be 25. So if you notice how they write this, the way they write that is they write it as an inequality. So they'll say you go from -10 in the x to 25. So this is a minimum of -10 and a maximum of 25. Now your scale is going to be the distance between the tick marks. So that's x SCL. And I would suggest that you make your scale 5. That way there'll be a mark at -10, -5, 0, 5, 10, etc. If you make it too small, it'll clutter the screen and you won't be able to see anything. Then you're going to go and change your y's. Your y needs to run from -70 to 35. So that's expressed like this. Are we getting it in there? I'm going to make my scale 10 because if you do it every 5, I bet that's going to clutter. So once you have that, then all you have to do is hit graph. What's it look like?
Oh, it went down and then it went.
So it comes down and goes back up? Is that what you're getting?
Pretty
You have something like this?
I wasn't expecting it. I like it.
Okay, so your scale is, your equation is off. Go back to y equals. Okay, so it's going to be x squared minus 15 times x. So just move it over on the arrows all the way to the end, and then do x. Not times. Just put in x equal there. Now graph. There you go, something like that, doesn't it? You got it? You got it. You guys got it? Over here? Okay, let's go back to your equation. See how it's a little bit different than Fiona's? Go to the equation to go to y equals. And then you have x, so move all the way over. You have x squared. There, now, minus.
You know, you can't say n and a half equal.
See how it shifted and moved? That's called a parabola. So your parabola opens upward, and it's got a minimum value that's over to the right and down. So it should look something like this. All right, there we go. There's a little bit. That's what we got. So now what do they want us to do? That's it, right?
That's it.
Okay, so now go back to your y equals, but don't delete anything. Leave it in place. And what I'd like you to do is, like, right when you go to y equals, the x is probably blinking, yes?
Yeah.
So use your left arrow until there's a box going around the blue color. And then hit enter. Oops. You can change it. No. You can change the color. I just want to leave it the same. Let's leave it the same, my bad. So what can we do? We can hit second quit. And then hit y equals. Go back over. Shoot. Oh no.
Fancy
Yeah?
I did some fancy stuff.
You did some fancy stuff?
Yeah.
There's a way to turn it off, and I don't know. Now I'm stumped.
I want magenta.
I'm sorry. I don't know why I can't. See, normally you can get it to turn itself off, and I'm not sure.
I like that. I like that.
Oh well, let's leave it blink. Go back, go down to y sub 2, the red one. Have I messed you up, or are you okay there? You get to y sub 2? Okay, so now we have activity number 2. We want to enter negative 7x squared plus 3x minus 4. There we go. Activity 2. Negative 7x squared plus 3x minus 4. Make sure you pay attention to the exponent, and you use the arrow to move yourself over so you don't end up putting everything into the exponent. And if you use the negative symbol in parentheses in front of the 7, it will work. If you write a minus 7, it will not work.
Good, it's a red line.
And then they want you to change the window. So go to your window and change it to what they give us. You might want to change your scale also so that you get a tick mark laying itself out nicely. You can just type over everything. You don't have to clear it first.
And there.
You got inequality. You got inequalities in there. Yeah, so go back to y equals.
Oh, that's pretty cool.
Come on, Art.
Oh, I made
Yeah,
that.
that's grass, though.
Oh,
I'll make that.
yeah, go back to the way it was.
I made my line pink.
Yeah, yours looks okay. That's what I have. Yep, now yours is coming in. What do we have here? Here's 3 is 3. And scale of 1. What is it, negative?
What did you not put in? I put mine in mine.
0.
Go to your window.
The scale of 5. So, like that. The blue line is from the previous equation. So this is part of it, and the red line is the blue bit. Good. Are we ready to go over here now? So,
There.
so you are going to go through the equation now? What's that? So go back to y equals. Now go to your window.
Always happy.
And then this is where you want to set your x to -3 to 3. And then you do the minimum.
I want Marvis's calculator.
Can you use the negative symbol down here in parentheses? You need to use that.
You can't change it.
Oh, you can, okay. And then that goes down to 3. You can just do type over if you don't have to delete it. And then you want to still use 1.
Okay.
And then here's your y, so you can put it in.
It's
So you and then the scale goes on 35. There you go, bingo. All right. What do we have next? Third one.
Yes, third. Yeah.
Actually, do you have both equations in?
Yeah.
Those first two?
Yep.
Yes? Go back and take a look at your graph. I'm going to show you something that's not right in this. Let's see, there it is. That's what it looks like. So, you look way up on the top, there's a key that says trace, right next to graph.
Yeah.
Click on trace. And what will probably happen is, on the top, it'll be blue and it'll say y equals x squared minus 15x. Is that true?
Yeah.
And then on the bottom, it'll say x is equal to and y is equal to some number. So what you're doing there is you are tracing, or you're moving along the line of that x squared minus 15x. So what I want you to do is I want you to move using the right arrow, and you'll see the cursor moving along the line. Is this true?
Yes.
And you move your left arrow, it moves back. So left and right, you move along that equation. Now what I'd like you to do is use the up and down arrow. And if you go up, everything will change to red, and you will now be sliding along the red line. The equation negative 7x squared plus 3x minus 4. Does that work for you guys?
Yeah.
Fiona? Marvis? Both of you? Okay. So that's how you use the trace function. And if you look, when you're tracing, it gives approximate x and y values as you are going along the line. So those approximate x and y values are down on the bottom. It's not exact. There are other ways to be much more exact. But it's a tool. It's a tool that can be used for approximation. All right, so now let's go to the third activity on the bottom of page 34. And I'd like you to go to your y equals, and I'd like you to clear both of those equations out. And we're going to put this back into the y sub 1. So now you have 5 divided by x squared plus 1, but we have to use parentheses. And they show you that you're going to type it in as 5 divided by parentheses x squared minus x squared plus 1, and then parentheses. And then set your window to what they call the standard window. And it says right there what you should do. You should go to zoom and then pick standard. Zoom is on the very top, right in the middle. And then you'll do Z standard. And when you hit enter, it'll take you back to a window which goes from negative 10 to 10 in both directions. You can always do that. You can always go back to the standard window if you wish. So this is the function that I get. So it's got a hump that goes right over the origin. Looks something like this. So you may not see the line. So we're gonna go to
I mean, magenta.
then you should see Z standard.
It was Griffin.
Just type the number 6 right now. Right here. You find it? Something like that? You good?
Yeah.
We good? Good, Marvin?
Yeah.
All right, excellent. So what is that? That's the third one, huh? Remember what those? 10 what? 50 or 45?
And something.
Yeah. 45, we're out at 45. So we still got 14, 15 minutes. Okay, now, sketching these graphs. If you have an assignment problem that says to graph the following equation and sketch a graph. So if I had this last one that we did here, the way I would put this into my notebook would be something like a little rectangle. There's the shape of my window. Put in wherever the y and the x-axes are and label them outside of the window like this. This is a common way of taking a graphing calculator display and showing it on paper. And then we'll do this. Instead of labeling the x-axis over here, we label it down here. So in the standard window, this is a -10. And then the x, instead of labeling a 10 up here, we would put a 10 there. So that's saying our window goes from -10 to 10 in that direction. And then over on this side, it goes from -10 on the bottom to 10 up here. So we would label as such. So these two values here are going to be with the y. You don't have to write y. I'm just putting that there for you. And those two values are going to be what goes with the x. And then you come in, and if you want to be real nice, you can do it with a different line color. It looks like this function did this, and then it went up, and it came down. Where does it appear that it crosses right here? If you look at your graph. Where do you think it crosses? If you hit the trace function, it'll tell you. And then you would put a 5 there. Because places that a line crosses the y-axis and the x-axis are going to become very important. And then you might go and say, well, this is the function y equals 5 divided by x squared plus 1. So that'd be a real complete way of showing your work if the book is asking you to graph and then sketch. Okay, I'm going to go back to y equals, I'm going to clear. So I just have one line to deal with. And then activity 4, graphing. So it's 5x times x, the quantity x minus 4 times the quantity x minus 3. And we want to try to match the window size with each of those 4 pictures. You do not need multiplication if you use parentheses. That's all right. You come hang out with us if you want. So I'm looking at one of our choices for window 3 is the standard window. So I just grab that thing in the standard window for now. And then you can match it up with the 4 choices that they give. How far are you guys?
I got that.
You got one? You have the standard window like that? So that's graph number graph one. So now you're just gonna go change the windows. Cool. How you doing? We have all kinds of extra stuff in there. Let's go back to y equals. And let's remove some of the first ones, like that one. Yeah, let's have this one over there to look at. Let's really do it in algebra.
Get some.
Yep, so then this is graph. It goes back up again.
Well,
So which one of those is this one? Do you see the tops of the curve still? Yeah, it's graph one. Okay. So these two go together. You don't have to do all of them, but pick another couple, one or two. Match them up by changing your window size.
I didn't know.
You did window number one, negative 6 to 6.
Oh wait, maybe that's the one standard.
Graph number one is a standard window. And I wouldn't even worry about the scale so much. Just get your window size down. And the point behind this is to see that there are some functions that you need to open up the graph window so that you see them more clearly. If you open it up too far, you lose detail. If you zoom in too much, you don't see the whole function. Have any of you figured out the window size for the second graph?
Oh, graph two is
Is window number one?
yeah.
Graph two is the first window, negative 6 to 6.
Yeah.
Yeah.
Yeah, and then the window two, graph four.
Window two is graph 4.
So window four must be graph three.
Yeah.
No.
Okay. So which one are you guys on now? Get it on any one of them, and then we're going to mess around with this a little bit. So you go to window to change your window size. That's where you put like negative 6 to 6. We use these negative 6 to 6, and then the black values. Ooh. Yeah, so you have an error. Syntax means that you typed in something that doesn't make sense. So do the quit, which is number one. And then go back to your window size. So your window size just doesn't make sense. Okay, negative 30 to 30. So there, you're zoomed way in. So go to the zoom. Yeah, that's graph 4. So use the zoom key. And now choose zoom out, number 3.
Oh.
You're not
No,
gonna-
it's good.
And then keep hitting enter and keep zooming out. Do you understand your answer? Click on zoom. And then go to zoom out. You can just type in number 3. Yeah, I got it. So all you do is pulling everything away. Or you can use that to zoom in as well. So did you guys find the zoom key? Go to the zoom key on the top center. And then you can just choose by number what you want to do, like zoom in or zoom out.
I don't know
Yeah.
what zoom in does, but I want to.
You don't want to zoom in anymore, so you go and go back to number 3. Window. That's right, by that, zoom. Zoom, and then number 3 for zooming out. Hit enter. Now hit enter again. And then, so it takes you out a little further, and out again. For you, if you go to zoom, you can zoom in. Number 2. All right, can I show you something else? So that's a zoom function. Would you do this? Would you go back to your window and change it to the -6 to 6 and -100 and 150. So change it to the window, the number 1 window size. Change to that so that you had that real nice full size picture. So you go to window
Yep.
and change your settings to the x-axis -6 to 6 and the y-axis from -100 to 150.
Yeah.
You're there? Okay, I want to get everyone there because these steps I'm going to show you, I want to do it just one step at a time. Are you there, Trent?
Mine.
Marvin? Go back to window. Go to window. So, it's still graphing, so you have to give it a second to stop. And now, -6. But now you're -60. Delete D down middle.
Okay.
-6. And then come down and do -100. Do a type over. There you go. That's not 150. Go. I'll go down to 150. Okay, graph that. Ladies, are you there? So I'm going to show you how to do a Z-box. There's a way to go and trace out, kind of like you would take and click with your mouse and hold and drag a square or rectangle onto a computer screen. There's a way to do that with this and zoom in on just that small little section. So what I have here is I've got this graph, and I want to zoom in on like just the top of the first hump that's on the left side. So here's what you do. You go to zoom, and if you look down at, there's one that, or number 1, it says Z-box. So you hit enter. And then you'll see a flashing cursor that you can move around with an arrow. And you move that thing around until you get it to an imaginary corner of a place that you want to drag and make a square. And you hit enter, and then you drag up and over, and up and over to make a box shape. And then when you're all done with that, then what you can do is just hit the enter key, and that little box shape becomes your screen.
That's cool.
So you can just zoom in on a section of the graph. So I ended up getting, you must have done it once already. So I just did something like this right here, and then I zoomed in on that box. Yeah, we zoomed in on different sections.
I zoomed in on mine.
So go to, so hit enter, and then drag over, oh no, you're not in Z-box right now. So hit zoom, number 1 is Z-box, hit enter, okay, now drag over, now hit enter again, and then drag over and up. And, okay, there you go, and when you make that shape, the section that you want, you just hit enter again, and now it's just that section. All right. Yeah, the math, they're no fun at all. Okay, so that's a lot of what you need, but it's not all of the activities. So let's just punt on homework. Come back tomorrow, finish the introduction to the lesson, and then I'll give you the homework. And you'll have a lot of time to work in class, which will be good, because you'll run into questions as you go. So no homework tonight, we'll finish the lesson tomorrow. Have a nice afternoon.